For the remainder of our reimagined time work, I want to try to actually teach you things that you would use next year in your senior math class. I want to continue what we were doing before all of this happened. So I'm going to continue the notes on page 46. And I'll probably have to do this in a couple segments, but that's okay. It'll break it up into a couple different days for you. Then I'll give you some time to practice those concepts that I'm going to go over. Okay, we've already written down definitions for the quadratic formula and the discriminant, but the quadratic formula is below. It's down here. X equals negative b plus or minus the square root b squared minus 4ac. Remember all that? I may sing it on here, I may not. We'll see. Okay, and remember the discriminant is the value under the radical, and the discriminant tells us some special things. That's on the next slide. Let's go. Okay, and I have written a couple things here, and I do want to rewrite them just so I can have them on here. Remember, if your discriminant value is greater than 0, that means it crosses the x-axis twice. You have two real solutions, and I even went a little deeper into that. If it's greater than 0 and a perfect square, so you get 25 when you do b squared minus 4ac, then you're actually going to have two real rational solutions, which means your answers will look like, I'll go over here and put rational. You'll have a fraction, or you'll have a decimal, or you'll have a whole number, or an integer, or you'll have, what else am I forgetting? Fraction, whole number, integer. You could have 0, that's a whole number. Anything that's rational, you could have that. Okay, if it's not a perfect square, then you will have two real irrational solutions, which means you'll have a radical in your denominator in which this number that's under here is not a perfect square. So your answer will have a radical in it. Okay, then if your discriminant value is equal to 0, then it just touches the x-axis at one point. You'll have one real rational solution. This is also often referred to as a double root, just to show that it counts twice. And then if your discriminant value is less than 0, you're going to have two imaginary solutions. Always say 2 complex or 2c. And that means you will have, let's see, this was irrational. For complex, you will have an I in your answer. You could have 3i, you could have 1/3 I, you could have 2 plus or minus the square root of 2 plus or minus I squared of 3 over 5. Anything that has an I in it could be your answer to these. Okay, so I actually skipped example 1, 2, and 3 and went straight to 4, 5, and 6 so we can talk about the discriminant more. Then we'll go back to 1, 2, and 3. Okay, so it says in exercises 4 through 6, find the discriminant and describe the number and type of roots. The description of the number and type of roots are going to be these kinds of description. You can have 2 real rational, 2 real irrational, 2 real, 1 real rational, 1 real rational, or 2 complex. Those are what we're going to use for the description. And then to find the discriminant, we're going to first of all make sure it equals 0, name a, b, and c, and then use b squared minus 4ac. Okay, so it is equal to 0, so my a value is 1, my b value is 34, and my c value is 289. So I'm going to do b squared, I'm going to have to grab me a calculator for this one, minus 4 times a times c. So let me grab my calculator. while I'm thinking about it. B squared is 1,156 minus, multiply next, 1,156. 1,156 minus 1,156 is 0. So then if you look back at that chart, I can't flip back to it because I don't think it would do well with the recording. But if you look back at that chart, when my discriminant value equals 0, then I'm going to have one real rational root. When it equals 0, that's when it just touches the axis. Remember, this is also called a double root. Okay, for the next one, number 5, if you notice, it does not equal 0. And I want us to get into the habit of always keeping our squared term positive, moving everything else to the squared term. So that's what I'm going to do. I am going to add 8x to the other side and subtract 3. So x squared plus 8x subtract 3 equals 0. A is 1, B is 8, C is negative 3. Then b squared minus 4 times a times c, 8 squared minus 4 times 1 times negative 3, 64, it's going to be a plus sign because a negative times, let me get my little red thing, a negative times a negative will make a positive. So plus 4 times 1 times 3, 12. 64 plus 12 is 76. Okay, so looking back at my chart, if you want to look back at yours while I talk through this, 76, is that greater than 0, equal to 0, or less than 0? Well, 76 is greater than 0. Then you ask yourself, is 76 a perfect square or not a perfect square? So hopefully you came to the conclusion that 76 is not a perfect square. So that's 2 real irrational roots. Now what that means is this one, when I solve using the quadratic formula, would have a radical in the answer. This one over here, number 4, when I would solve it using the quadratic formula, I would not have a radical in my answer because it's rational. Moving on to number 6, the only thing I need to move is this 3q to make it equal 0. 4q squared minus 3q plus 1 equals 0. A is 4, B is negative 3, C is 1. So B squared minus 4 times A times C, negative 3 squared minus 4 times 4 times 1, 9 minus 16 is negative 7. And please, this is my disclaimer, I am a human and I make mistakes. If you see any mistakes, please forgive me. I do make numeric mistakes. Sometimes I just can't help it. My humanness comes out. Okay, so negative 7. Looking back at that chart, is negative 7 greater than 0, equal to 0, or less than 0? Negative 7 is less than 0, so that means I'm going to have 2 complex solutions, which means this one will have an I in the answer. Okay, moving right along, I want to do the examples for solving using the quadratic formula. Remember what the quadratic formula is. I may sing it really quick. Remember, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you remember that song. It's been a while. If you don't, then if you go to YouTube, I'm sure you can find someone singing that song, or I'll let you listen to some other songs. Okay, what I like to do, and this is the reason why I did 4, 5, and 6 first. I like to find the discriminant value first so I know what my answer is going to look like. So that's the way I'm going to do all 3 of these. Number 1 is equal to 0, so I'm going to go straight to naming A, B, and C. I'm going to do b squared minus 4ac. negative 7 squared minus 4 times 1 times negative 18. 49 plus 72, I think. 49 plus 72, 121, I believe. Okay, so 121, is that greater than 0, equal to 0, or less than 0? Greater than 0, equal to 0, or less than 0? Well, hopefully you know it's greater than 0. Is it a perfect square or not a perfect square? And it is a perfect square, so that means I'm going to have two real rational roots. I will not have a radical in my answer. I will have two fractions. I will have two whole numbers, or a whole number and an integer, or two integers. I'll have those kinds of things. We probably won't do decimals unless I ask you to change it to a decimal. So now I'm going to fill into x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then if you notice, I had already done b squared minus 4ac. So when I sang b squared minus 4ac, I just went ahead and filled in 121. Now I'm going to take the square root of 121, which is 11. Then I have to remember this plus or minus means I have two problems. 7 plus 11 divided by 2 and 7 minus 11 divided by 2. So that means I have 18 divided by 2 and I have negative 4 divided by 2. So I'm going to come over here. My two answers are x equals negative 9 or x equals negative 2. You're welcome to leave them like this or write them in a solution set. Does not matter what order. Just please, please, please do not write them as an ordered pair. Let me show you and then I'll cross it out. Don't write them like this. That says x is negative 9 and y is negative 2, so don't do that. Don't do that. Exit out. Okay, so let's move on to the next one. It does not equal 0, so I'm going to subtract 4w and add 1. A is going to equal 1, B is going to equal negative 4, and C is going to equal 1. I'm going to do b squared minus 4ac first. Negative 4 squared minus 4 times 1 times 1, so 16 minus 4, which is 12. Okay, is it greater than 0, equal to 0, less than 0? Okay, it's not these, so it's greater than 0. Is it a perfect square or not a perfect square? And it's not a perfect square. So I will have a radical in my answer. Okay, so this time it's w. W equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now when I look at this, 12 can be simplified. 4 plus or minus. Remember, there's a perfect square in there. So w is going to equal 4 plus or minus 2 square root of 3 over 2. Now I want you to look. This is a fraction. This fraction, I don't know why that's so dark. This fraction has these numbers that aren't under a radical. I'm going to write them back in. Maybe it'll be okay. I have 4, 2, and 2. Do those three numbers have a common factor? And hopefully you know the answer is yes. This is a fraction. Reduce that fraction. You never reduce the number inside the radical. It stays the same. But you reduce the fraction that's there. So w is going to equal 2 plus or minus the square root of 3 over 1, but I don't need that over 1. There's my answer. Okay.